Okay, so in this video we're going to learn about lesson 1.5, which our learning target for this lesson is I can solve equations using real number properties and inverse operations. So this is really a 7th grade topic about solving equations, but we're going to make sure we practice and we know how to solve certain type of equation, so that way when we get to a little more equations, you are successful in that area. So in lesson 1.5, you should see these notes here, and there's just a ton of examples of solving equations. So if you get to a question in the practice and you're like, I'm not sure how to do that, a good place to look is here. So this kind of shows you how to do a lot of different problems. I'm also going to show you, it gives you some good tips too, like what kind of steps to take. And stuff like that. But I'm going to show you a couple examples, specific examples in this video right now. So the first example I'm going to show you is an example that looks like this. So I'm going to show you -3 times 1 plus 6r equals 14 minus r. Okay, so the first thing I want to do, and you might have heard this before, is if you like to split up both sides of the equal sign, so that way you don't combine like terms where you're not supposed to. So the first thing I might do here is I might distribute that -3. A lot of students will distribute this 3 and not take the negative there, but if it's a negative number, you have to distribute the -2. So -3 times 1 is -3. -3 times 6 is -18. And then on the other side, I'm just left with 14 minus r. Okay, so then now I have variables on both sides. So the first thing you're going to want to do is make sure you have all the variables on one side. So I might add this r over here. You could add 18r on both sides, whatever you prefer. It's going to get you the same answer. So whatever I do to one side, I do to the other. That's the addition property of equality. So then I'm left with -3 minus 17r equals 14. So now I have to get this variable alone here, so that means I got to get rid of this 3, so I'm going to undo it by adding 3 to both sides. And I should get -17r equals 17. And then my last step is to get that r by itself, and those are held together by multiplication, so that means I undo it with division. So I get r is equal to 17 divided by 17 is -1. Okay? So that would be how to solve an equation with variables on both sides and with distribution in it. The next one I want to show you looks like this. Oops, this should be a -39. Okay, so if you ever see parentheses, that's usually the first thing I work with. So I'll just distribute here. So 2 times 5, and then 2 times -6. I don't do anything with that 4k because I'm not distributing anything there. So 2 times 5 is 10k. I wish I had that much money. And 2 times -6 is -12. And then equals -3k minus 39. Okay, whenever I get to this step, I always ask myself, is there any terms I can combine? And if you see here, I have 2 variables on the same side that have k in them. So I'm going to combine those together. So -4 plus 10 is 6k. Minus 12, I just carry the 12 down, equals -3k minus 39. So now I have variables on both sides, but there's only one variable on each side, so that's a good sign. So the next thing I like to do is I like to get all the variables on one side, and I always try to keep things positive. You could subtract 6 on both sides here, but it's just going to give you more negatives, so I like to try to get everything positive. So I'm actually going to add 3k to both sides. And so 6k plus 3k is 9k. So I'm left with 9k minus 12. Those undo each other, so I'm just left with -39 here. Now that k is almost by itself, I just need to undo that 12. So I'm going to add 12 to both sides. Negative 39 plus 12 is negative 27. So I'm left with 9k equals negative 27. And then my last step to get that k by itself is going to be to divide by 9. So I got k equals negative 3. And remember, you can always check your answer by plugging this negative 3 back in for k. Okay. All right. And the last thing I want to talk about is looking at equations in different ways. So I'm going to write this equation here. 20 equals 5 times the quantity of negative 3 plus x. And I want to talk about two different ways you can solve this. So your first instinct might be to distribute that 5, because anytime you see parentheses, you think distribute, which is not a bad thing. So 5 times negative 3 is negative 15. 5 times x is plus 5x. I'm going to add 15 to both sides so I can get that x by itself. I'm left with 35 equals 5x. And my last step is to divide. I'm left with x equals 7. Notice I'm not switching that around and I'm not putting the x over there just because it's easier. If you have x on this side, you have to keep it on this side. Okay? So anyways, that's one way to solve it. The answer is x equals 7. There's another way to solve it though. So if I do that same equation, we are sometimes so trained to see distributive property that we forget there's another way to do this. So this works really well when this side is divisible by this. If you think about it, 5 is really being multiplied with that parentheses there. And so to undo multiplication, I can actually do division by dividing both sides by 5. And so 5 divided by 5 is 1. And I'm left with negative 3 plus x. I don't need the parentheses anymore because there's nothing being multiplied to it. And then 20 divided by 5 is 4. So then all I have left to do now is add the 3 to both sides to get that x by itself, and I'm left with x equals 7. So that's two ways to solve it, and this one is definitely more or less common because we automatically just think distribution every time, but it's actually the shorter way to solve it. So those are just some kind of examples. So in this video, I was able to get you to look at distributing and then variables on both sides, which is what I really wanted to cover today. So there's a ton of practice for this section. Do as much as you feel comfortable with, but I would ask you to do at least 10 problems. Okay? All right, and challenge yourself. If you find that you're doing 10 of the same problem, that's not going to help you. I would try to do as many different types of problems as you can because that's the best way you're going to learn. Remember, this is not for correctness, it's just for participation. So the harder points, the problems you try, that's probably your best interest. Okay? If you have any questions, please ask me.